So far, we've had a cursory look at our data set and checked for missing data. Now we're going to start looking at our data in a bit more detail. One of the most useful things to do as part of exploring data is to visualize it. It's true what they say, a picture is worth 1,000 words. And data visualizations don't just come in handy when it comes to, say, presenting a snazzy final report to your boss, your team, or your client. Data visualizations also help us make sense of our data at the exploration stage. How so? Well, there's two things that we want to get a sense for right now. The first is the distribution of the data, and the second are outliers in our data. So what kind of visualization could we use at the exploration stage to spot both outliers and see the distribution? Well, enter our friend, the humble histogram. The good old histogram is the first data visualization technique that we're going to cover. Histograms are pretty simple. They just show us the number of instances in the data that have a certain value. A histogram is just a bar chart that shows us the frequency of a particular value. In this green histogram, we've got the values on the x-axis and the number of occurrences on the y-axis. The taller an individual bar, the more occurrences there are in the dataset. And by plotting all the bars next to each other, we get a certain shape. That shape is the distribution of our data. Now, I've created this green histogram here to show you what a normal distribution would look like. You can always spot a normal distribution by this very reassuring bell curve, meaning a lot of the observations are around the center or the mean of the distribution, and very few observations are at the edges. The reason that we care about distributions in the first place is because they tell us a great deal about our data. For this dataset on Boston house prices, there's 13 independent variables, including everything from the average number of rooms to zoning restrictions to the pupil-teacher ratio in the schools. And each of these variables is measured differently. And a histogram is a good starting point for understanding what these features are, how they're measured, and what the data actually looks like. Another reason why I bring up distributions at this stage is that many statistical tests and estimation techniques make certain assumptions about the kind of distribution. Now, we're going to revisit this concept at the analysis stage when it comes to our regression residuals. And it'll be very interesting to see what kind of distributions those have. So this is something to keep in mind for later. We're going to see if we get a bell-shaped curve like this at the analysis stage or not. Now, let me ask you a question. What do you think the distribution of house prices will look like in our dataset? If you had to imagine the distribution of house prices in your head, what would it look like? Now, spoiler alert, the house prices are going to look nothing like this green histogram right here. In fact, the distribution of prices looks like this. As you can see, it's much more messy, right? Well, that's real data for you. And also, our data has outliers. At the right-hand edge of this distribution, the normal distribution has very, very few observations, but the actual house prices have some pretty high bars right here. Now, I'm not sure which houses these are in Boston, but the people living there are pretty well off, to say the least. All right, so now it's time to write some Python code and learn how to draw histograms like this, because I suspect you're not just going to take my word for it when it comes to these charts. So let's head back to Jupyter Notebook. Let's start by inserting a markdown cell and putting the following subheading here. Visualizing data. Histograms, distributions, and bar charts. Now, to draw a histogram in our notebook, we're going to make use of the matplotlib module. So we're going to have to add some import statements at the very top. So I'm going to scroll back up, and I'm going to add the following import statement. Import matplotlib.pyplot as plt. And at the end, I'm also going to add the %sign matplotlib space inline. And let me hit Shift Enter. Now, this last line, if you recall, was so that our charts would show up when we export our notebooks. So this line of code is really Jupyter Notebook specific. Now, to draw our histogram, we're going to use our matplotlib module and call the hist function. So we're going to write plt.hist, open parentheses, and now we need to supply some arguments. The first input to this function is what should be plotted on the histogram. In our case, we're going to start plotting the values from our target, namely the house prices that are given in thousands. This was inside our data frames price column, if you remember. So I'm going to write data, square brackets, and then the string price in all caps. On the next line, I'm going to put plt.show and hit Shift Enter. And this is the output that we'll get. Now, the thing about this histogram function is that we can supply more arguments to customize the look and feel of our histogram. For example, we can supply an argument called bins, and bins is going to determine how our prices are grouped together to form the individual bars. So let me put bins equal to 3 and hit Shift Enter. If we put bins is equal to 3, then we only get 3 bars. All our house prices are grouped into one of these 3 bars. Now, this might be a little difficult for you to see. So what I'm going to do is I'm going to make my chart larger, first of all. So we can do this with plt.figure, parentheses, fig size, and then supply a tuple. I'm going to say 10 and 6. So this is going to make my chart a lot larger. But I want to make this more explicit still. I want to show a black outline of the actual bins in this chart. So there's something called edge color, EC, that I can supply as an argument to this histogram function. So I'm going to say EC is equal to, and then the string black. And now my histogram will look like this. So now we can really see that I've only got 3 bins. All our house prices are either grouped into this first group here, up to 20,000, or the second bar here, between 20 and say 35,000, or this third bar here, between 35,000 and $50,000. Now, of course, you can play around with this input here. So we could also go the other extreme, right? We could have, 100 different bins. Hitting Shift Enter on this will make our chart look like so. In other words, by setting the number of bins, we can set how granular we want our histogram to look. Now, I tell you what, I'm going to go with 50. I think 50 is a good compromise between 3 and 300. And this conveys the information in the price column quite nicely. Now, if you come back to this chart in 3 months' time, you're probably not going to know what it's showing. So let's add some labels on the axes. So I'm going to write plt.axLabel, parentheses, price in thousands, and plt.value y label, parentheses, number of houses. And I'm going to have to format this as a string. I can't put it in there like so. So I need single quotes at the beginning and a single quote at the end. Now let me hit Shift Enter. And voila, it's a lot more clear. We've got the frequency on the left and the dollar price in thousands on the x-axis. So far so good, right? But wait, what was that? Did I just hear you say you want to style this histogram to make it look prettier? Okay. Let me try and channel my inner designer and choose a different color. To do that, I'm going to add another argument to my function call here. And that argument is going to be called, surprise, surprise, color. And it's also going to be set equal to a string. Now, I can add a hex code here as an input. Now, it turns out that my inner designer is actually super lazy and recommended that I use a website like Material Palette to pick a color instead. So you can see that this is just one of the many websites that curates a color palette for you. And I'm going to pick this blue one here, these two blue colors. And then I'm just going to copy this hex code right here. And this is the hex code that I'm then going to paste in as an argument for the color right here. Let's see what this looks like. Voila. Cool. So I think we've got a really nice histogram here from matplotlib. And now you can also see for yourself that the histogram here ties out with what I've showed you earlier on the slide. Trust but verify. Am I right? You know, apparently this saying was Ronald Reagan's favorite Russian proverb. Trust but verify. If you happen to know any other funky Russian proverbs, please do let me know in the Q&A section. But moving on. The thing is, we're actually not stuck with just using matplotlib for data viz. There are quite a few other lovely Python modules out there that do a fantastic job at data visualization. And I can't wait to introduce you to an alternative to matplotlib. And that's a module called Seaborn.